Welcome, algebra students. This is Mrs. Parsons, and today we're talking about applications of inequalities. So we're doing your favorite thing in the world, which is word problems. So make sure that you have a piece of paper and your notebook ready to take some notes. So we have a drama club, which charges $6 per ticket. The equipment rental fee is $176 per day. What's the minimum number of tickets sold per day in order to break even? So every day they're being charged this fee, $176. And in order to make up for that, they have to sell tickets. So I'm going to define a variable. I'm going to say T is going to stand for tickets. And how much are they charging per ticket? Well, it's $6 per ticket. So that is a multiplication problem. And I know that they're being charged $176. So now I've got to determine what my inequality sign is going to be. Does the number of tickets being sold have to be greater than or less than 176? Well, it definitely has to be greater than, because we want to make money, right? We want our ticket sales to be more than what it costs us per day. Now I have to ask myself, can it be 176? Can I have this greater than or equal to? Sure. If I have the greater than or equal to, that just means I break perfectly even. So now I'm going to solve this by dividing by 6 on both sides. So that's going to be T is greater than or equal to 176 divided by 6, which is 29.3. But can we sell 0.3 of a ticket? No. So I know that my tickets have to be at least 30 tickets. Okay, we're going to round up, because if I only sell 29, that is not going to be enough. I need to sell 30 tickets. Now we want to write an inequality to represent each situation. So you must be at least 18 years old to vote. So we're talking about age here, so I'm going to use A. And if you have to be at least 18 years old, let's think about that in terms of an inequality. Does that mean you can be less than? Does it mean it has to be greater than? Okay, if it's at least, we know you have to be greater than or equal to 18 years old, because you can be 18 years old, but you have to be greater than that. Your age has to be greater or equal to 18. You can spend at most $25 at the grocery store. So what I spend at the grocery store has to be at most $25. What does that mean in terms of an equal sign? Does it mean I can spend more than $25, which would be a greater than sign, or less than $25? Well, it means less than. Now think to yourself, can it be $25? Can I spend $25? Yes, I can. So that's the less than or equal to. The amount I spend at the grocery store has to be less than or equal to 25. Kendra needs to consume a minimum of 2,000 calories. So I'm going to say C, 2,000. Okay, and minimum means that that is the least she can eat. So she can eat more or that same amount. So the calories that she consumes has to be greater than or equal to the 2,000 calories. You must be at least 65 years old to order the senior breakfast. So we're talking about age again, so I'm going to use A again, okay? And at least means you have to be greater than or equal to 65 years old. Okay, our next example says an elevator can hold up to 1,500 pounds. Write an inequality to describe the weights. It tells you to use the variable W the elevator can hold. And then we want to graph the inequality. So I know the weights can hold up to 1,500 pounds. So think about this. You're riding in this elevator. It can only be up to 1,500 pounds. Does that mean it can be greater than or less than? Hopefully you're saying less than if you want to live on this elevator ride. And it can also be equal to. If we have exactly 1,500 pounds, this elevator should be okay. Okay, so the weight has to be less than or equal to 1,500. So if we are graphing this guy, we get our number line ready. I'm going to put 1,500 in the middle here. Okay, and then you might put, I don't know, 1,600, 1,400. Okay, open or closed circle. If we're looking at the inequality, we know it should be a closed circle. And it is shaded to the left. We want all the numbers less than. If we go to the right, that is more than, and your elevator will come crashing down, and we do not want that. Now, in this example, Ben operates a t-shirt company, and each month he pays $175 to rent the building. He also pays $2 to make each shirt. Then he sells the shirts for $11.50 each. We need to write and solve an inequality that can be solved to find how many t-shirts Ben has to sell to make a profit. So this $175 that he pays to rent the building, that's coming out of his pocket. He's going to pay that even if he doesn't sell any shirts. And if he doesn't sell any shirts and he has to pay to rent the building, he is not making any money. And he's also paying $2 to make the shirts. So this is his out-of-pocket cost. Where he's making his profit is this $11.50 that he's selling the t-shirts for. So if he's selling $11.50 per shirt, I'm going to say S here, okay, that cost has to be greater than or equal to his out-of-pocket cost, which is $2 per shirt, plus that $175 he rents the building for. So on the left-hand side is what his money-making expenses are. Here is what his out-of-pocket expenses are on the right-hand side. And we know that we want his money-making to be more than his money costing. Does that make sense? Okay, so now I have to solve this, and we're going to solve it just like we solve any other inequality, and we're going to get the s's on one side, so I'm going to minus 2s. So 950s has to be greater than or equal to 175, and then I'm going to divide by 9.5. Okay, so I'm going to take my calculator. 175 divided by 9.5. So S has to be greater than or equal to 18.4. Okay, nobody sells 18.4 of a shirt. Okay, even if you're selling a crop top shirt that's really only half a shirt, it's still a shirt. So how many shirts does he actually have to sell? Well, he needs to sell 19 shirts. If he sells 18 shirts, it's not going to be enough. He's got to round it up to the 19 shirts. All right, in our last example, we actually have a system. So we're going to be writing two equations. Kennedy's working 2 summer jobs. She makes $11 per hour babysitting and $8 per hour clearing tables. In a given week, she can work at most 17 total hours. That's going to be important. And she must earn no less than $160. So X is going to represent her number of hours babysitting. Y is going to represent the number of hours clearing tables. And we're going to write and solve an inequality and determine one possible solution. So when you are writing systems of inequalities or even systems of equations, when we get into that, you're going to notice that a lot of it has to deal with money. And all the money is going to stick together into one equation. So we're talking $11 per hour. That's talking about money. So $11 per hour babysitting, that's going to be the X, plus the $8 per hour clearing tables, right? Money. Now I'm looking for my other money. It's 160 here. And she has to earn no less than $160. So the inequality that goes here is greater than or equal to. Okay, and then she can work at most 17 hours. So this is a quantity thing. So the number of hours that she works babysitting plus clearing tables has to be at most 17 hours. So at most means less than or equal to, okay? It cannot be more than 17. So we are going to solve these equations. All right, so if I solve these real quick, I get y is greater than or equal to negative 11 eighths x plus 20, and y is less than or equal to negative x plus 18. So let's graph these real quick. So this one starts at 20. That's my y-intercept. And I go down 11 over 8. Down 11. All right. Well, if my dots will stay. And I draw a really nice line. It's going to be solid. All the way through. And I'm going to shade up. Okay, and my second equation, I'm going to start at 17. And I'm going to go down 1 over 1. Keep doing that. And this should hit at 17. Okay, and that's also going to be a solid line all the way through, and I shade down. So anything that is in this little slice right here will be considered a solution. So I might pick 15 and 1. That means she's working 15 hours at her babysitting job and 1 hour clearing tables. Okay, so that could be a solution, but you could pick anything that falls in here.